Okay, this is stream 11. The stream is going. I'm going to be resuming work on my grammar tonight. Bonus stream. I'm filling in rules for the expression grammar, which is a pretty big one. And I've ported over the integer. Let's move on to decimal. Don't mind if I do. Literal decimal. Decimal. F64. Okay, so expression here needs a literal decimal F64. Okay, and then EXPR is where we're going to do the test. Okay, so this is valid integer. Let's have another valid, and this one's a valid decimal. Token decimal 1.23. Don't know why I just typed that twice, but I did. Let's run that, make sure it works. Great. Let's move on. Let's close some of these things that I don't need to have open anymore. Delist. Don't need that open anymore. We're gonna need that, so let's move that over to here somewhere. I don't need that open. Actually, what does Lex print out now? Stage gif.fmt less. Okay, so it's printing out locations. I think I want to like have it format that differently. Right, this T is no longer just a token, it's a tuple of location, token, location. So let's have it say this. I'm changing my mind. So it would say that, and then maybe what? A colon, and then a start dash stop. Like that, maybe? And that we're going to put into T. How about if we just name it? So start, token, end. Then I can put token back in here. Actually, then I can also put start and end here and not have an argument. Maybe not colon because it's hard to see that. Not parentheses. What about if I do like a literal brace? Literal end brace. What is, can I not do that in a print statement? Oh, two of them. Okay, can do that. Same thing here, right? Yeah, okay, what does that look like? That looks better. At least with my eyes, I can see that better. Maybe more than one space would be make it easier to see. Oh, even better. How about 3 spaces? Oh, that's a lot better. Perfect would be if like we actually did a new line if we knew that the next thing would go over 80 characters, but then I'd have to start tracking the line length, and that's a little more complicated than I care about doing. So I'm just gonna leave it at that. So we can close that guy. Okay, expression. What's next on expression? Strings. We can do that. Literal string, string. Okay, and then here I want to keep these sorted. And that wasn't sorted before. Okay, everything else was sorted. Where's S fit in? Q, R. Yeah, S would be next. Token, string. Actually, I don't know if it's called token string. I think it is, but let's try to make sure it is. It is string. String, string. Imagine that. Okay, and then valid string test. So let's do the multi-cursor thing. So token string like foobar into. Hey there, Danik020. You're the first one to chat tonight. It's been a while since you were on Twitch. Am I still working on the text-based game? No, I can't work on that now. It's one of the conditions of the job I have. Can't talk about my job, can't do open source, can't do app or game dev. So I'm sticking to these side projects that are in Rust. So last year I made this keyboard in Rust. As in, I designed the hardware, built it, and then all the firmware's in Rust. And then this year, it's mostly just resurrecting old projects that weren't in Rust and like turning them into Rust. Because I got really into Rust when viewers watching me work on that game, and it was all in C++ at the time, were like, "We really think you'll like Rust," and I'm like, "Oh, I don't have time for that." No, really, we think you should look into it. And I'm like, okay, fine. I grudgingly look into it, and I'm like, whoa, why didn't I see this language before? Why did it take me so long to try this out? So I never really went back after that, and I don't get a chance to do any Rust coding at work, so it works out well. I do not Rust at work, and I do Rust not at work. You switch on C++ as well? See, I think we'll always have the languages we know with us, and we'll always be able to go back to them. The new languages are always like really nice and shiny looking, even if it's named Rust. You know what I mean? C++ is always going to be here. Yeah, we'll always have to deal with it. There's just like cool things that I get to do here that I don't have in C++, and maybe a lot of it's just the tooling, like the fact that I can press this button or this button and just run the test I just wrote. And it's failing because we don't recognize. Oh, I didn't write the rule for it. Like you could probably set this stuff up for C++, but I mean, it was just so easy to set up with Rust. All I had to do was have Rust Analyzer installed and pull in the test case crate. I feel like Rust forces you to really think about your code. Answers are great. We had someone in chat the other day who said the opposite. They said errors suck and are hard to understand, and well, I don't know if they said anything about thinking about the code, but they had a very opposite opinion about errors, and I'm like, that's interesting, because like some people really like the errors. Yeah, the crates are nice. They haven't worked on C++ in large projects. Well, in C++, you sort of have a choice. You can have error types. You could also have exceptions, right? Or maybe a mixture of both now that they have, what is it? Well, they have the equivalent of optional or option in Rust. In C++ is called optional, right? C++ errors are up. there's the C++ exceptions, there's structured exception handling, and then there's errors the same way you do it in Rust or something like that, where it's like possible return value. Oh, compiler errors, that kind of error. Here I am thinking about runtime errors because probably because you used the word error capitalized, and I thought of the trait, the error trait. Yeah, compiler errors. I think it depends on what kind of errors you encounter when you're learning Rust. If you start learning Rust and you start to run into borrow checker or async code errors, and you're like, oh, I hate this because it doesn't help me, then you maybe get a bad first impression. But if your first impression of errors is that they really help you understand, then yeah, you get the opposite experience. If you're doing the handling stuff, you're the one who makes the choices there. True. Okay, that test failed, I think, because I didn't have the grammar in here. Oh, where am I? Expression? Yeah, this one. So in a second, I'll do a recap of exactly what I'm doing here. Just let me fill this in. And then go back and make sure the test runs, valid string test, right? Yeah, there we go. So I made this tool about 5 years ago that given a specification for a file or a protocol or any other kind of binary data, the tool will compile this into a data structure in memory and use it to parse a file that matches this format by doing an in-order traversal of that data structure. So you can imagine GIF is the root node of a big data structure, like a tree-like data structure. Header and logical screen are the first leaf nodes. And then you might have zero or more data blocks and then a trailer. So these again become child nodes of the structure. And then like inside header, it has its own child nodes. I guess these would be the leaf nodes and header is like an intermediate node, right? I'd like to point out that the language is describing things sort of with a sort of duality. Everything here looks like both a structure and a function because it's got structural elements, like these are the constituent parts of a GIF file. But we also have like functional elements like loops and conditionals. Loops turn into arrays. So like in the end, GIF will have a data array of 0 or more data elements. So this was all in C, and I'm porting it to Rust. There are 3 parts of it. There's the lexer, which turns the input program into tokens, which I was just kind of playing around with here. So here are the tokens that are emitted by the lexer when it studies this, right? That's an identifier, there's a brace, another identifier, semicolon, identifier, semicolon, then a keyword. So that's all of this, right? So lexer identifies them tokens, and we're also retaining like where in the file, like the line number and column number they were, just in case we get like an error in the error message, we can tell the user where the error was in the original file, right? So that's the first of the 3 steps that the tool does. The second step is what I'm working on tonight, which is the token stream is mashed against a bunch of grammatical rules to reduce it down to that data structure I described a little bit ago. So at the very top level of the grammatical, the grammar rules is something called a formats. Let me scroll all the way to the top. So here's formats. It's a sequence of format specs. So you have like 1, and then 2, and then 3, and so on. Each one of these is like a little data tree. The grammar builds them up as a list, and then I have this callback to call back into part 3 of the tool, basically to add another tree to the list of trees. Like basically, there's a tree for every format, and they can refer to each other, just like GIF refers to header over here. And a individual format it looks like a function and a structure. Like I said before, there's an identifier, maybe some arguments, left brace, statements, right brace. So you see how this goes. The original lexer and parser were in Flex and Bison formatted input files, and in Rust I'm using For the lexer, I'm using logos, which is pretty cool because you just annotate with these attribute macros all of the things like what white space means, what are your sub patterns, which ones are your tokens, and then which ones need to have callbacks to parse the matches of regular expressions. So it's kind of like what I used to give to the flex input, only it's much more tightly bound to the output token enum, and it's much more concise. I like it. The second part, the grammar rules, the parser generator, also called, I'm using Lollipop, and this is kind of like Rust, but it's also kind of like the Bison rules that I'm familiar with. It's like Bacchus-Nor form, where you have a grammar rule and then a list of what the elements of that grammar, like what to match. In other words, if we see this sequence of things in our stack, or as we're looking ahead at what we've received from the lexer, then we would reduce that to that. And when we reduce it, we run this code. Usually the code will gather together things from the elements and kind of package them up and put them into the output. So Lollipop is kind of similar. We say, like, for each grammar rule, what thing it's going to output, and then each of the possibilities, the things that form that would be reduced to that rule, have the job of producing a value of that type. So like an optional ID list is an option of a list of IDs, right? If there's nothing, then you get a none. But if there's something, then you get some ID list, and you get that from the middle token, which we parse as, again, if there's nothing, it's just empty vector. If there's one thing, it's a vector with one thing. And if it's more than one thing, they have commas between, and then we build them up one at a time by pushing into the vector from the left-hand side, where we're adding the right-hand side to it. And then that gets packaged up. If we have parentheses around it, you can see how it goes from there, right? Hey there, Lobsang too. So that's my description for all the lurkers and all the chatters. The original grammar goes kind of long. It's like 1,000 lines long. I'm hoping it'll be not as long in Rust. It does seem to be a bit more concise. So like, we're working on expression right now, and there's lots of different kinds of expressions. And I think it was around here somewhere we had the literals. Yeah, so like it took 5 lines to describe, well, 6 if you count the comment, to describe an integer literal. We did it in 1 line. So if the trend continues, it'll be not more than 150 lines versus 1,000 for Bison form. So we just added string, we had integer and decimal, so we've done these 3 rules. I'm just kind of going down the list. Once I have all the possible expressions, then we can build other grammar rules that depend on expression. So kind of building it from the bottom up. I started with the rules that were like very, very simple and didn't depend on anything else, like optional comma, optional look ahead symbol, optional identifier, identifier list, optional identifier list, and now expression is used everywhere. So we're working on that, and it doesn't depend on anything else for some of its rules. Some of the other rules, like key values, that can have an expression inside of it, so that they're codependent. So I'll have to add them together, basically. But let's add the ones we can add right away. Let's do the nil one. That's really easy. So a nil is a literal nil in the output. So that would be nil. And we have to have like an expression nil. So nil goes where? Right here, alphabetically. That's a token nil. Okay, and then expression type has to have a nil in it as well. Okay, no value associated with that. See, this is one of the things I really like about Rust, is that it's really easy and concise to have an enumerated type where variants can have attached values. To do this in C or C++, you'd have to have a union, and then you'd have to have an enum, and then you'd have to package a value of that enum with the union, and the enum would basically say which one, so it would have like 4 different values here. And then like just by convention, you would use one member of the union if the enums value was a certain thing, but then the compiler wouldn't enforce that. And you can't make some of these have constructors, whereas in Rust, they can totally have their own constructors. It's tightly enforced by the compiler. You can't use string if it's literal integer because they're not of the same variant. It's really nice. Okay, I need to have a test for this nil. So a valid nil, right? Valid nil. So it's just token nil. Not literal nil, it's just nil. Run that test. Cool. See, super easy to add a test and run it. Going back to the format. So we've done nil, string, decimal, integer. Ref, we don't have the grammar written for that, so I can't do that. I can't do this one for the same reason. Can't do that one. If I did expression list, we could make a literal vector because that's just expression list with a comma at the end. So maybe I can do that if I do expression list. Can't do that. Maybe I can do that. Can't do that. I can do that if I do key values. Again, expression list is used in a lot of places. Okay, here we go. We can do this because it's a self-referential thing, right? An expression in parentheses just discards the parentheses. So we'll do that this way. I'll do the rule here. So this would be left paren, and then E for the expression, and then right paren gets reduced to expression. Just gets reduced to E, right? So then a test for that. So this would be, I guess I can pick whatever I want. So I'll use an integer. In fact, I'll put that right after. No, keep the literals together. In fact, why don't I have like a little comment here saying literals? And then here we'll have like, actually, I don't know if I can have a blank line there and a comment, but I guess I can because that didn't go away. This would be like compound. Well, this is only going to be valid for this one thing. Maybe it doesn't, maybe I don't need comments. Second guessing myself. I do that a lot, especially when there's no chat. I get nervous. Okay, so this is not valid integer. This is sub expression in, or yeah, parentheses. So token would be L paren, and then some token like an integer, and then actually, yeah, this would work, right? So we should get an expression. It should just be reduced to that. Yep. So let's run that test. Cool, it worked. So something in parentheses, just the parentheses get tossed. Okay, so then what's next? Okay, here we go. Numerical negative. I forget what that meant. Should I look that up? PREC in Bison? Contextual precedence. Often the precedence of an operator depends on the context, etc., etc. Bison precedence declarations can only be used once for a given token. So a token that has one precedence declared in this way. For context-dependent precedence, you need additional mechanism, the prec modifier. It declares the precedence of a particular rule by specifying a terminal symbol whose precedence should be used for that rule. It's not necessary for that symbol to appear otherwise. So it's that terminal symbol. And it's written after the components of the rule. It's effective to assign the rule, the precedence of the terminal symbol, overriding the precedence that would be deduced for it in the ordinary way. So here's how it solves the problem of unary minus. First, declare precedence for the fictitious symbol named u minus. There are no tokens of this type, but the symbol serves to stand for its precedence. I see. So it like means it's like higher precedence. Now the precedence of u minus can be used in specific rules. Oh, I see. Because we already had the minus here. And this is saying use the precedence of negative. I don't know if I need that for our rules. I guess where we might need it would be if without it, we can have an ambiguous grammar. So if we get a error about an ambiguous grammar, then I'll worry about it. So this is just numerical negative, right? Unary operation negative. So that makes me think we're going to have like a second level enum for which operation. So we'll have one called operation, I guess. And then it'll have variance negative, flip, and other things. And then it might have one or more arguments, right? Actually, a unary operation would just have one operand. So then should the data go with the operand? Let me think about that. It would make it cleaner. So let's make another module. So we have expression, then we'll have operation. Hold on. Yeah, okay. I think I know what I want. So make that a mod, and then that means I have to make a file called operation. And then just like expression, we'll need to derive debug and partial equal. Okay, so one will be a unary. Or do I need to say unary? Can I just say negative? Negative. And then there's an expression inside of that, right? But here's where I got to be careful because I can have an infinite data structure, right? If I do this, I'm going to get an error that's saying that I need to import it. But I'm going to get something else as soon as I put operation in here, right? I'm going to get that. We have an infinite sized enum. So one of them has to be boxed. Which one are we going to box? I kind of feel like we should box the operation. What that does is it makes it a pointer to something on the heap. So it's a level of indirection, meaning the size of expression is no longer infinite because it's infinite if this way, because an expression can contain an operation, which can contain an expression, which can contain an operation, and we just repeat infinitely, right? When I put it in a box, now the expression could have a pointer to an operation, but the pointer has a fixed size of the size of a pointer, and it's not the size of an operation, so we divide it into two things. Are you A SWE, a software engineer? Yeah, I am. Are you? Little Sus, 1998R. How are you doing? Okay. I think my Roomba ran into trouble in the other room, and I'm contemplating whether I should go rescue it or if Mrs. Ryan was going to go rescue it. So the rule we wanted was unary minus. So that's minus some expression, right? Yeah, it's here. I guess I'm putting it where it was in the Bison as well. So that's minus. So this is expression operation. Box new operation negative E. Okay, we can close that so we can see the whole line. All right, and then I don't have minus declared right here. Minus maps to our token minus. Okay, then let's make a test. This is going to be negative. So we have minus some integer, right? Should reduce to operation. Box new. Operation negative. Expression literal integer. And then enough in parentheses. Too many? Just enough. Okay, operation needs to be, why, I don't want to qualify. I want to import it. Okay, we'll put it here. Operation. It's probably going to say that it needs to be public. I don't know if I made it public. Oh, no, it worked. This is too long. So how about put it on another line. Run the negative test. Use of undeclared type. Right, in the grammar, we need to actually pull in the type operation. We don't get help from the editor here because this is not technically a Rust file. Okay, back here. Run it. Pass. Great. Hey, why don't we, while we're at it, why don't we run all our tests? Oh, we failed. We broke the empty token test and we broke the invalid token test. Oh, because all the alternative rules need to be listed there. Okay. You're 25, a year left of school, and tips have only had one internship. Did that internship go well? Did you like the internship? If you liked it and the internship went well, see if that company will hire you. If you didn't like it, then probably while you're still in school, get another internship. Your goal should always be to get an internship at a company that you like before you graduate, because then they'll probably hire you on right after you graduate and you'll smoothly transition from school into work. Having the internship will give you that initial experience and make you more confident. It'll also give you money while you're still in school. So that should be your goal. Tips for getting another internship. Whenever you have a break between exams and studying, just look for any career fairs that are going on. Get your resume up to snuff. Use ChatGPT if you must, but get a good resume and just scattershot it everywhere to every company you can. Especially the ones that you would like to work at, even if you think you're not good enough. still apply. Mention your first internship heavily in your resume because it's actual job experience, and companies care more about that than anything you've done at school. Hopefully your first internship you can still talk about. It's not under non-disclosure agreement. If you could talk about it, then find something interesting to say about it that'll grab resume reviewers' attention, right? Or make it sound exciting even if it wasn't. Because companies are going to be looking at tons of resumes and they'll be bored to tears, and then they'll see yours and they're like, whoa, this one looks different. This person actually did something interesting. I want to talk to this person. Okay, yeah, I broke the case where we had the alternatives, right? Empty and invalid. So, like, these used to be the only alternatives, but now we have a whole bunch. I don't like the repetition, but we're going to have to do it, right? I'll just list all the ones that they had. So it was, I'll keep it in the same order they have it. Decimal, integer, and then it was left paren minus nil and string. L paren minus nil. Oh, I had thought of something else, little sus, that you can do, which I can't right now because my job doesn't let me. What you can do while you're still in school, if you are into software, find an open source project that you think is interesting and try to like go on under the list of issues or features that aren't done yet that are looking for someone to work on them, and just pick one that you like and just try working on it. Get a pull request or two in. Then you get experience working with others on a project, and if it goes well, you can put it on your resume. You can even turn that into a job later if, like, the group you're working with likes you and they're sponsored by a company. You can get into that company. So there you go. You were a full stack intern. It was okay. The company wasn't tech heavy, so it wasn't too nerdy, if that makes sense. Well, did you like it? If you liked it, then see if they'll take you back. If they liked you. Strager, how are you and your fine people doing? Hello, it is code. I'm working on a parser in Rust right now. I hope you had a great stream, Strager. I'm assuming that you have to go either sleep or take a break. So yeah, I hope your stream went well. Only hiring full-time, you did not get a job offer? That sucks. Ask them when you're available to work full-time. So ask them back and say, hey, remember a year ago I was an intern. Do you have anything for me? Rust sucks, too complicated. Hey there, 10x programmer. Glad you're here. Even if you think it sucks. My mic is crazy good. It's Audio Technica. You know why I got this mic? Because my kids were so loud that I had to find a mic with a hypercardioid pattern so that you literally can't hear anything. If I move my head over here, you just can't hear me now, which is great if you have screaming kids around you. C sucks, too simple. Well, we have both ends of the spectrum here. Too simple and too complicated. So hello, everybody. Let me give you another rundown of what I'm doing. I have to do this every hour or so. So I'm writing the Rust version of a C++ tool that I started 5 years ago that kind of does a similar thing to this right here. You've seen this, I think, possibly some of you, called Wireshark. You can, in Wireshark, you can click on a packet that you might have captured off of your network, and you can see the raw bytes in that packet, and you can click on a byte or a range of bytes, and it'll actually tell you what it means. So it's a protocol analysis tool, right? Well, I thought to myself at one point, I happen to be learning different file formats, like movie file formats and image file formats. And I'm like, if I don't have a program that can decode that movie or play or whatever, how am I going to learn this file format? I have the specification. I know what I can do. I can write the specification in a language that looks like a function and a data structure, and then I can make a tool that can compile this language into an abstract syntax tree in memory, and then do an in-order traversal of that data structure while taking bits in from the input, and give me something like this, right? If we were to look at our test file, which to you and me looks pretty crazy, but if we look at it like a computer would see it like this, the first 3 bytes, signature, next 3 bytes, version. How did it know that? It compiled this, which told it that the header has a 24-bit string signature, 24-bit version number, and we even had some conditional logic in here to throw an error if that's not what we saw. So it's great. It doesn't have a nice user interface yet. It's all in text, but it does do some interesting things, like I can use it to grab the width and the height of a GIF file and go all the way to the end and know that there's 61 frames to the GIF. And I can even go up and at some point we'll see, if I search for time, I think, or just the number 3 or equals 3, because I know it's 3. What is it? There's a 3 somewhere in there. I'm not gonna be able to figure this out, am I? Where is it? I wanted to show this. I'm not gonna be able to. Was it step? Okay, somewhere in there is the frame rate of the GIF, right? And it happens to be 3/100ths of a second per frame. And my tool can figure that out just by parsing all the bits. So I importing it to Rust because on my stream, I'm really into Rust, and I like to take old tools that I like that I've written in the past, or maybe new ones that I'm working, and get them running in Rust. Yep, so this is a domain-specific language. The domain is data parsing and analysis. It would be open source if the company I work for allowed me to do that, but they don't, so it's not. Maybe someday if I retire, then I'll check this into GitHub, but until then, I'm sorry. You can only see what I choose to show 25 lines at a time. What about multiple protocols? You can have as many format definitions as you want, and they can nest. So if I wanted to, I could describe all the internet protocols in one file and then have something like Wireshark. I just don't have a nice GUI yet. But that's one of the things I hope to get to in this stream, is after I get this ported to Rust, then I'm going to play around with making a GUI front end to it. Do not steal. Do not steal what? The name of the project is the DataDisintegrator. Yep. Let me do the allow because it is bitchin' cool. Bitchin' is an okay word. It is now permitted. Low sensitivity marks are ideal. Yeah, but you have to get really close to it. That's one problem that I have. Where do you start studying and practicing in C++? Pick an open source project that uses C++ and attempt to work on a feature that they want, or find a bug that no one's looking at yet. Really? AutoMod doesn't like the fact that you said you a big nerd. We're going to allow the term you a big nerd. Strager's a big nerd? Who's a bigger nerd, Strager or me? Probably Strager. Use 010 editor templates. There's your parser. Let's look at your parser. If you were kind enough to raid me, the least we can do is, that didn't copy the link. Copy link, I said. There we go. Copyright Strager. That looks really familiar. You even have conditionals. So one thing that's different is you don't have it under, you don't have it nested like I do. You just have it kind of like a recipe that goes from top to bottom, which is fine. But it is pretty similar to what mine looks like. So what language is this in? Is it also in your own domain-specific language, or is that a thing? That must be the thing, right? 010 editor is the thing. GUI presentation is easier to follow if you don't do nesting. I ended up doing nesting for a very specific reason on mine, and that is a lot of times they're self-referential, and a lot of times they have loops. And I don't know if 010 editor lets you do this, but mine turns a loop into an array so that when we decompose this GIF, data is actually an array rather than being a scalar or a single element, right? It's every loop populates the next index of data, which is kind of cool. You can also just use it to describe like the color table. So color table is 3 arrays, or I could describe it differently and have one array and each element has one of each of these. If I just write it a slightly different way. I like it. I like what I did. It's inspired by the MPEG-4 format. If you look up, I don't think there's a public version of it, but ISO.IEC 14496-12. Is there a free version of that? Be cool if there was. Usually these things cost a lot. There's a download PDF. Yeah, see, it's like $60. But that's not the right one. I want 14496. Yeah, the base ISO base media file format, right, for MPEG-4. I don't know where to get a copy of it. I think there's a free one somewhere, but the way they describe the elements of that file, like the structure and like how to parse it, is they do it in a sort of a pseudo language that's kind of similar to what I'm doing. And I was kind of inspired by that. Spec is a nice language for the binary description. The spec? Oh yeah, some specs. Like another spec that does that is H.264. Which I can't remember the ISO version of it, but if you look up like H.264 spec, oh, it's an ITU spec, that's right. AVC is another name for it. Yeah, I wish I could show you this, but it's all hidden behind these standards bodies paywalls. But if you were to get a copy of the specification for advanced video coding, they describe their bitstream the same way. No one wants ASN1. That's an old school way of describing structures, right? Check FFmpeg source for the MPEG-4. Yeah, but that's source code. I was referring to like the way the specification defines the grammar of the bitstream. They do it in a similar way. So just take my word for it. So yeah, I'm working on porting stuff. So I already have the lexer done. So the lexer was originally written in Flex. So it's just a bunch of regular expressions and then how to parse the match of that regular expression. Or if it's a simple reserved word, then it's just a one-to-one. Then you'd run a tool called Flex on that and it would generate C code, which is like a lexer program. I picked a crate in Rust that does it in a much more cool way. It's called Logos. And it's done with attribute macros. So you just put a whole bunch of attribute macros around your token type, and then the variants in the token type. And they kind of replace all of those pattern matching rules and other things. So like you can define some sub patterns. Our skips are our white space, right? And then here are our reserve words and other special tokens. And then here's our funky regular expressions for literals. And string is really wacky. Looks like that. That's too 5 head for me to do, so I leveraged Stack Overflow, of course, and I gave them credit. And yeah, so within just the definition of my enum, I have enough for Logos to generate the full lexer for me. So the funkiest thing was, and I get one of my VIPs was making fun of me, justifiably so, that I chose to make a state machine for parsing escape sequences and strings. And yeah, I should be laughed at because probably would have been better to use a regular expression since I'm already opening that Pandora's box down here anyway. So I should have been, probably should rewrite that as a regular expression, but you get the idea. The Lexer's done. So if I were to run that on this, I don't know if I did that yet, but here we'll run it. So it's like you might expect. That's an identifier. That's a brace. That's an identifier. Another a semicolon. Another identifier, semicolon. There's a reserved word. So that looks like this. The numbers after the tokens are the span. So the line number and column number at the beginning and end for the corresponding token. So like the GIF is the first 3 columns on line 0, because we count from 0 in programmer land, even if normal users start with 1. So the entire program is just a string of tokens. It's up to the grammar rules to turn this token string into, make grammatical sense of it, essentially, like the semantic meaning of this, in order to construct the data tree that we will use to parse the binary files later. Hey, Owen Coates. Things are going good. Strager rated me. Thank you, Strager. I like to be crushing those bits. We're disintegrating our GIFs into little pieces. Each line is one piece of a GIF file, or it's a composition, because it is a recursive, or what do you call it, a tree-like structure. We have the leaf nodes and we have the interior nodes. Yeah, we're destroying GIF files. How are compile times with Logos? I haven't measured it, but it is pretty dang fast, because they boast it creates ridiculously fast Lexers. So I'm sure it's ridiculous. I don't need it to be too fast, so I haven't really studied it. Not the GIF files. It was a format that we were able to describe completely in 260 lines, so not bad, right? It actually is functional. You can do something with it. It's used today, which is insane because it was made in 1987. What else can you say was invented in 1987 that we still use today? Not much. YAML needs to stop? Well, good thing I'm not using it. Can you achieve blazingly fast? Depends on what you're blazing, I guess. So yeah, 3 parts of my tool: Lexer, done; parser, working on it; and then the third part is the actual data processing, not there yet. The parser, second and the middle part of my tool, originally was using GNU Bison to generate the parser generator, or it is the parser generator. The parser is another word for what takes that token string and reduces it to abstract syntax tree. It's a bunch of Bacchus-Nor form grammatical rules, and expressions are probably the most complicated one, because there are a lot of things that can be an expression. You could have something less than something else, less than or equal, equal, no, not equal, blah, blah, blah. You can have something in parentheses. You can have a function call. You could have vectors, maps. You could have literals, and you can even have nil. So each of these is a separate grammar rule that reduces to an expression. In what I'm using in Rust as the Rust equivalent of GNU Bison is something called Lollerpop, which has a really silly but kind of cool name, because Lalr, L-A-L-R, stands for look ahead, left to right, which is the technical term for the category of parser that both GNU Bison and Lollerpop generate. And it's pop because why not? Make it sound like lollipop while you're at it, right? So it's still kind of Bacchus-Nor form, but it's more Rust-like. This looks like more traditional. But the rules are pretty much the same, but they're a lot more compact. We're fitting things on single lines, mostly because there's a lot of boilerplate overhead to do the same thing in C that we can do in Rust with just a single line. Interesting that there's no standard language for parsing binary data. I just think it's a niche thing, right? There are not very many apps that need to do it. You might consider the plugins for Wireshark. Maybe they have a standard language. I haven't looked into how they do it. But my understanding is Wireshark has a plugin or extension API that lets you write your own analysis tools for new protocols and stuff. So I'm guessing they have some kind of language for doing that. It would be ridiculous not to have something because there's a lot of similarity between protocols. Why not have an abstraction to help make it simpler, right? But I don't know. I'm just guessing. So yeah, I'm building up the different things that can be expressions in my language. And yeah, we just got to get through the list. What was I going to do next? I had this. I had just done that one, I think. I don't remember. Did I test it? Oh, right. I had tested it and it worked, but then I had noticed that we had broken these test cases. So I wanted to run the tests, all the tests again, and make sure they're all passing now. 32 tests passing. That's what we want to see. You know, Wireshark has dissectors. That's the name of it, dissector. But when you write a dissector, do you have to write it from scratch, or do they give you a language that you can leverage? Hopefully it's the latter. Yep. Well, for those that stuck around after the raid, welcome. Let me know if you have any other questions. I'm going to continue working for, I don't know, maybe another half an hour, and then I got to go sleep, but then I'll be back in the morning. So flip is a bitwise not, and there's a flip operator, and I don't remember what that was. What's flip? Flip. Flip is the tilde. Interesting. So if you have tilde in something, then it's a unary bitwise not rather than a numerical negative. Okay, so this shouldn't be too hard, right? We would add another kind of operation called a flip expression. And in our grammar, we have to add flip. I'm trying to keep the names the same as what I had in the C++ version here, just so that I can keep them comparable, even if flip is a whimsical name that I wouldn't use today. We're still going to use it. So yeah, very similar to minus, right? So this will be flip some expression. It's an operation, but instead of negative, it's flip. So let's make a test for that. Here, just like negative, only it is flip. So it's flip goes here, and flip goes there. Run the test. It passes, so we move on. Next one up, logical not. Same thing, right? So we should be able to get through these pretty quick, right? It is called not expression. Okay, so then what is not? Oh, it's bang, okay. Not. Then not goes here. Okay, and then the test. Because this might get a bit tedious, I might go over to something else for a little bit. Do you see how I did that with multi-cursor and it retained the case? That's a nifty little plugin called case something. Multiple cursor case preserve. I am not sponsored by them, but I still think it's a pretty awesome plugin. See how it I changed all those flips to knots, but then it retained the case. One of the most awesome extensions out there. Just saying. Okay. How to look on the interwebs looks like it's just C. Oh, that's sad. What's the advantage of my language compared to BNF or PEG? With mine, you don't have to actually write any code. You would just write the binary format and then you just use it. I guess. Unless you know of a tool that you can write this in BNF and it can parse a file with it. BNF isn't Bacchus nor form, right? That's just grammatical rules. You still need something that actually goes that third step and uses the abstract syntax tree to walk through it to parse some data. And maybe PEG does that, but I don't know what that is. There was one thing a viewer mentioned that looked very similar to my tool, and it's also in Rust, and I forget what it is. But I don't mind if I'm not the first one to do that. This is just something I was passionate about that I already have written in C, and I just kind of, I don't know, want to have fun writing some Rust version of it. PEG is similar to BNF, so it's just a different way of doing it. I mean, we could have alternative languages. The tool I'm writing doesn't really care what the input form is, as long as there's a parser for it. And you still get the same abstract syntax tree in the end, right? And we'd still walk through the data the same way. So I just kind of like this because it's pretty compact and it kind of matches how you would describe it in an international spec. So yeah, just going with that. So okay, expression in our grammar. Let's pin that. Did I test the not? I think I did, but I don't remember. Yeah, I did. Okay. So we're moving on from that to binary operation is a member of. So it's something in something else. So here's the first time we're going to have a binary operation. And in is just the reserved word in. So we have a operation called in that has. So I can do it two ways. I can have expression. Why did that not auto type it for me? There we go. We could do it that way, or we could do it this way, which I'm kind of partial towards because it assigns names to them rather than needing to remember the positions of things. The disadvantage is that we always have to use them by the names now. Maybe with a binary operation, the tuple is a better way of doing it because the position in the tuple sort of implies that it's the left or the right. So maybe we keep it like that. So then expression I don't need to change because it's just another kind of operation, right? So this would be, yeah, so this would be LHS, which is an expression in right-hand side expression goes to one of these. And let's put it on another line because it's going to be complicated. If you missed it, the reason why we're boxing our operation is because an operation can have an expression in it. And if you don't break it into an indirection between the two, you'll have what Rust calls an infinite or undeterminate sized type. Because you could have an expression with an operation with an expression with an operation with an expression, you know, etc. till infinity. By putting it in a box, when you see box in Rust, think pointer. Specifically, pointer to something on the heap. So if you have an expression, the size of a box is always the size of a pointer, no matter what the operation is. That allows us to know the size of expression because it's no larger than the size of the maximum sizes of these types, and this size now is always size of a pointer, right? String is also like the size of a pointer plus a size because internally it has a pointer to the actual character array. So even though the string could be any size, is held indirectly. So expression now has a finite size, even if we don't know how long the string is and we don't know how complex an operation is. Alternatively, I could have had the expression has an operation, but then the operation would have to box all the expressions. I thought that it would be better to have only one box rather than having all of these be boxed. I hope you agree. Hey there, Stripe Monkey. How are you today? Yeah, we're just getting through all the grammar for expressions. By the way, did you know the keyboard I'm using has, I don't know if you can see it, probably not, but there's like extra thanks to, and one of the names on there is Stripe Monkey. Because last year I made that keyboard that I'm using right now. And while I was working on the keyboard, Stripe Monkey had a ton of suggestions and helpful ideas. So thank you again. Every time I look at my keyboard, I'm reminded of the wonderful people who helped me make it. Okay. So this should not be not, it should be in. And then we'll have left-hand side, right-hand side. That. Okay, and then I need to have a test for that. So test case. It doesn't need to have semantic correctness. We can just have like integer and integer and it should work. It doesn't have to make any sense. Let's make them have different numbers. So like 10 and 42. So this should be an in with two expressions in it. One is the literal 42 and the other one's a literal 10. And yeah, let's do some indentation. Not that, but like, let's do it that way. Just so that it's slightly easier to read. And this is in. Must have an error because when that test case goes away, that usually means that you have an error. Where is the error? I don't see it. Do you see the error? Oh, I don't see it. Okay, we'll let this find me the error for me. Oh, so the grammar has a problem because we didn't define what in meant. We have to define it down here, right? In means the token in. See if that makes nope. Well, unless I need to build it again. Oh, we have an ambiguity. Okay. Ooh, we get a really nice error message too. The following symbols can be reduced in two ways. Flip expression in expression could be reduced like this. Alternatively, it could be reduced like this. Lollipop does not yet support ambiguous grammars. So in the original grammar, that might be why we had this precedence rule here. Got some ice cream? I don't have ice cream though. Now I'm sad. That's okay. I'll have ice cream 3 days from now, probably. I can wait 3 days. So yeah, the question becomes do I need to do something like that to disambiguate the grammar? I should probably study more what that error was saying. Flip expression in expression could be flip expression and then that in something else, or it could mean flip expression in expression. Yeah, that's true. So we need to reduce it some way. It's also saying the same thing about minus and not. Yeah, so how did we do it here? I wonder if it's because in Bison, the order of the rules determines the oh wait, no, it's not that. It's that the these ones are given precedence orders somewhere near the top, I think. Or is it in yeah, it's right here, right? That's right. These are left and right associativity rules. So how do you do it with Lollipop? There's got to be a way to do it. See Lollipop manual for advice on encoding precedence. So I guess that's what we got to do. We got to look at them. We have to RTFM, read the effing manual. Okay, let's read the manual. They probably have a section on it. Well, maybe I should look for the word precedence. Here we go. Handling full expressions. Blah, 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 blah. Oh, okay. The idea of precedence, of course, that expression, we want to do multiplication. It doesn't have any built-in features for giving it, mostly because I consider these to be creepy. What? Is this the author talking? In the first person, they just broke so many rules about documentation. You never use the first person in documentation. Also, that's sort of a lame excuse. Consider those to be creepy. Pretty straightforward to express precedence in your grammar by structuring in tiers. For example, here we have the non-terminal expression, which covers all expressions. Is this the way we do tiers? Oh, I see. So they're like different levels of expression. Factors in a series of terms that are multiplied by. Finally, a term is either a single number or using parentheses an entire expression. Abstracting from this example, a typical pattern of encoding precedence is to have one non-terminal per precedence level, where you begin with the operators of lowest precedence, add in the next highest precedence level, and finish with the bare atomic expressions like num. Finally, you add in a parenthesized version of your top level as an atomic expression, which lets people reset. To see how wide this works, consider the two possible parse trees for something like 2 plus 3 times 4. Right, exactly. It's ambiguous, right? Blah, blah, blah. So they said that that's one way. Is there another way we could do it? No, he just goes on to saying, okay, next topic. Was there another area of the manual that talked about precedence? Yeah, this is probably something different, right? Factor that out using a macro. What? Oh, I see. That's if we wanted to make it look nicer. Okay, so he's suggesting that I just make up different kinds of expressions then, based off of my operator precedence. So that's lowest to highest, right? So if we're just dealing with the ones that we have, it didn't like in. It didn't know the order between in and not. So these should be higher precedence, right? Not and flip should be pretty high up here. Right, here it's near the end. The only thing higher would be dot or the parentheses, brackets, or braces. And what is left versus right again? Does that mean that like if you have not something, or if you have not flip, it's you do the flip first and then the not, you go from right to left. Is that how it works? I think that's how it works. Yeah, are we gonna have trouble with that where it's still gonna be ambiguous because you can have like not. Actually, it should be okay because as long as we get a higher precedence than everything else, it's just always going to be right associative because there's only an operand on the right hand side, not the left. Okay. So then I guess we can call all of these things to be like higher precedence. What if I just put like a number on this thing and we just start off with 0. And we're going to go to, we're going to have expression 1 have the in thing in it. This seems lame to me, but maybe it'll work. That this... How does that work with this 2 different tiers thing again? Expression plus factor. A factor is a factor times a term. A term can have an expression in parentheses. What if I wanted like... Oh, an expression can be a factor. I see. So if I had like an in here, I would have an expression, the higher one, 1, and then a lower one to the right. But you can reduce a higher one to a lower one. So it's always higher and then on the left and lower on the right. That's probably how you do, that's what left associativity? No, that's right associativity, right? Because it's going to want to group, well, let me think about this. I can't think about it, it's too hard. I think if you swap this, if you had factor on the left and expression on the right, it would flip the associativity. But I don't know which one's left and which one's right. What if it's like something plus something plus something? Well, to get a plus, it has to be an expression. So it would have to be like A plus B plus C, which makes it left associative. Okay, that answers the question. If it's expression on the left and factor on the right, it's left associative. If it was factor on the left and expression on the right, it would be right associative, I think. So applying that to my own thing, in was supposed to be non-associative because why? Actually, what does that non-associative mean? Let me look that up. Because I know what left means, I know what right means. I don't know what non-associative means in Bison. Bison non-associative. What does that mean? Non-associative specifies no associativity, which means that X op Y op Z is considered a syntax error. Okay, good to know. So then I need to arrange my rules so that with the in rule, you can't chain them together. So that would be like, it has to be level 0 on both of them, right? Because if I allowed a 1 there, then you could have something in something go into that and have another in. So I think that's the way it has to be, right? That's a non-associative one, where it's the same, it's the lower level on both, right? And then we have to have the other rule here, right? We have to have E X per 0 just reduces to E. That's what they had, right? Oh, they didn't have an arrow. I guess by default, it just fills it in for you. Okay, so I can just say that. Yeah, I can just say that. Okay, cool. So then we don't have an in here. But all my expers need to be expers 0. And then he had a rule to like go back to the top, right? I think this was it, if you put it in parentheses. But I didn't want to have to put it in parentheses, so how do I do it? How did he print? finish with the bare atomic expressions like num. Okay, the parenthesis version, which lets people reset, sure, but like what if I wanted to like say like not something in something else? I wouldn't be able to do that, would I? It would force me to put it in parentheses. Um, yeah, so here's the reset rule, right? Not expression one. I mean, not, it's, if it's in parentheses, you can reset. Yeah, so for these rules, I can't put a one there, can I? Well, let's see what we get when we do this. So the problem is here, what? Found keyword in. So the grammar parsed. Okay. So what's the deal here? I have a syntax error here somewhere. Where is it? 1, 2, 3, 1, 2, 1. I don't see any problem here. Oh, is that it? No expert parser in grammar? So yeah, that's here, and I guess that means we're breaking this up, right? So should I have a module for each tier then? I guess that makes sense because otherwise it's going to get too big. So we'll make this the let's make a copy. So we have expression level 1 and then one for level 0, our innermost. Okay. Look at that. It put a 0 in there for me. Isn't it nice? So this is test expression 0. This would be test expression 1 with the 1 here. I guess I put the 0 in. It wasn't done for me. So this is a 1, whereas this one needs to be a 0. Okay, and then at the top level, I need to say so that we have that not the top, the test level. We have to say we have a mod expression 1 and a 0. Okay, error. Where be the error? Here again. So I don't know what's wrong there, but we're going to fix this anyway because expression 1 is really just in, so we're going to delete all the other test cases. Okay, all the other test cases go away. Except for the negative test cases, we should probably have, I mean, not negative, but the error test cases we probably should keep in there, right? Except for, well, yeah, we're doing it. So why do I have that? Oh, right, too many tokens. So for too many tokens would be, let's not do that for expression level 1 because expression levels, it would just go to expression 0, right? It would be something and then an extra token. Yeah, let's not do it here. Okay, so then don't need invalid either, right? Or do I? Maybe. We'll keep that. Empty makes sense too. Okay, so what's the bug here? I don't understand. Found keyword in. Oh, are we not allowed to use in? What if I put an underscore in front? That was it. It just couldn't be a reserved word. Okay. Oh, the other file still has it. So let's fix the other file, expression 0. So we just need to remove that in one, right? Yeah, just remove this one. Okay, so all the expression zeros should pass. They don't. Oh, because these probably need to be updated. Decimal, integer, left paren, minus, nil, and string, and we're missing blip and not. Blip goes after decimal. Blip and not goes after nil. I think it's actually keeping them in alphabetical order, which is pretty sweet. Not gonna lie. Okay, so run that again. We passed. Okay, and then level 1 expression failed. Because this is all, oh, it's the same thing, right? So this goes the same thing. Two passed, one failed. The invalid token one also has a list in there. Okay. Cool. Okay, so that means all of our tests should pass. Yep, 37 tests all pass. So, problem is I can't say like not something in something else unless maybe I allow an expression 1 here, and then I'm worried about that. I'm worried about these becoming ambiguous again. Maybe I don't need to be worried about that, but let's see. Yeah, so it's ambiguous if I do that. How is it ambiguous? Not something in something could be not something itself in something else. Okay. It's because of it's because of the non-associativity, right? If I had made it left associative, then this would not be ambiguous, right? No, it's still ambiguous. How is that ambiguous? I thought I fixed that. It could be... Oh, do I allow it to just a 0 to become a 1? No. 0 can't be but a 1 can be a 0. Is that what it's trying to tell me? Yeah, that's what it's trying to tell me. A 1 can be a 0, so if that's expression 0, it can be turned around to expression 1. Okay, so that it's still ambiguous. Doing that alone didn't fix it. So what do I do here? How do I make this work? This can't be an expression 0. And the old grammar, how did it do this? I did it some way. How did I do it? It was with this, right? Somehow? Okay. Right, it had something to do with that, plus the fact that these were considered like higher precedence. And in is non-associative. Non-associative, which again, it means you can't have A in B in C. So to prevent that, the in has to have things which can't feed back. Okay, I think I know what I need to do. So back in the grammar, these expression zeros it can't go there because then it, sorry, that's not it. No, this solves the non-associative problem because you can't put an expression 1 there. An expression 1 can't be in Oh no, it can. No, but it can't go the other way around. A 0 can't be a 1. So that can only be one of these. It can't be an in. The problem though is that it doesn't know if that is one of these. If we have not A in B, it doesn't know if it means not A in B or not A in B. The solution to that is to make the not right associative, right? And there's no way I can say the order of expression 1 and 0 is there. If I didn't have that, then it wouldn't be a problem. Actually, what happens if I do that? Okay, well then it's just a lot of my tests broke. Why did the flip break? Flip expression. Oh, because that. All right. So that's why. Because if those are ones, then they have to be in expressions, which we didn't want. Oh, wait a minute. With the associativity rules, it can't be an in. Right. So that has to be an expression 0 right now. All of these do. This can be a 1 though. Because the parentheses disambiguate it. This makes it right associative. So if it's not something, this can never be something in something else. So that fixes it, and then I can put this back, right? Now it should work. Yeah, okay. That did it. I am allowed to say not parentheses A in B, but if I did not A in B, it would actually always parse to be not A in B. In fact, let's have a test for that. So a test for that, I guess, would go in expression 1, right? Yeah. So here we go. Let's say like this is like not A in B. So then the tokens are not integers are nice and friendly, so we'll just use those, right? So if we have not something in something, then it will be an in, and then the sub-expression will be an operation itself. Like this. And that will be a not 0, or not 10. In 42. There we go. That's exactly what. And if we wanted it the other way around, if we wanted not 10 in 42, we'd have to put it in parentheses. Let's say, can I put a comma here? It ignores the comma. Not A, then in B, and then we can say, I'm using then as like a placeholder for like how it's grouped. So we can say not then A and B. So to do that, we have to actually put parentheses in here, right? L paren. And then, because it's a parentheses, we'll just do it like this, and then it kind of looks like it's parenthesesed. In fact, I can do it this way, and then it's obvious. Not left paren, right paren, so it's easier to read. Then it's the other way around. Then the not and the in flip. Holy late Raimu Nightshade, dude. Yeah. I actually should probably go to bed because I need to wake up in time to do this stream again in the morning. I'm trying to figure out how to do associativity in Lollipop. So apparently you can't do what you did in what I used to do in Bison, which is assign associativity to operators to disambiguate grammar. I got errors, and so I had to go to the manual, and they had to explain to do operator precedence, they have precedence levels of grammar. So instead of having a single expression with plus, minus, times, and divide, they broke it up into two different grammar rules with different names, and then they have weird rules for associativity. So left associativity, so you put the outer on the left and the inner on the right, and then right associativity would be the opposite. And then non-associative, you'd have the same level of, you'd have like factor something factor, then it's non-associative. And you have to have these funky rules, like you have to be able to, it has to degenerate down. So like an outer can be just an inner. And that's how you get an expression to be just a number. It just degenerates all the way down to number. And then you reset by allowing the most degenerate expression can have a parentheses and be the top again. So the top allows you to like invert rules, which is why you'd use parentheses at all, right? Is to break the associativity of operations. Like normally 2 plus 3 times 4 is 2 plus 3 times 4. But if you wanted to do 2 plus 3 times 4, you put parentheses around it, and that inverts the rule, the precedence order. So I used to just do it with assigning associativities and the order in which we define these, declared the order of operations. But we can't do it in Lollipop, so I have to be a little bit more crafty and actually break my expressions up into different precedence levels. And right now, in is lower precedence, so it has to go in the outer. And then it's a non-associative operation, so you can't have x per 1 on either side. In other words, you can't have A in B in C. It's a syntax error. You can only have you can't have an in expression on either side. And this is how we're doing it, right? So at this level, you can only go down 1, either with an in or not an in. And at that level, you stay at that level for all these right associative operators. And this is the reset rule if you have parentheses. And then as we go, we'll add other precedence levels, and we might end up with as many levels as this, which would be kind of scary, but not too bad. Looks like there's going to be a lot of things between in and those right associative operators. So what right now is x per 1 is probably going to be x per 7 or something like that when we're done. But yeah, I'm getting tired. It's probably, let me add one more. I was going to do this test, and I was maybe add one more kind of expression, and then we'll continue tomorrow morning because I'm getting tired. So we have not A and then in B. So not goes with the A, and then that's in B, 42. And then this is the not, then A and B. So not is the outer one. And then the inner one is the in, which has two things in it. Those two. Have too many parentheses. That one has too many parentheses. Okay, let's test that. That should work, right? Yeah. Of course it works. Everything works the first try in Rust. Didn't you know that? Sleep doesn't exist. So I should just keep going until work at 12 hours from now. Should I have a 12-hour stream where I don't sleep? I'm sure you guys would love that. But I would be a total wreck for work tomorrow if I did that. Don't fall for the lies. I wish sleep could not exist. I could just turn off the need for sleep for a while. And don't tell me that tomorrow's Friday and I don't have to sleep because I don't have to work on Saturday. Because I can sleep after work Friday. Because I'll totally do it and I'll be really unhappy that I did. Let me do one more rule and then I'll continue in the morning. Okay, so probably I did a sane thing, which is I ordered this in the same order of operations. Actually, I probably didn't. Actually, let's look at the order of operations and just pick the next one up. So that would be the next one up from there, right? Someone's phone is ringing. I wonder whose it is. Hold on, let me go get that phone. That might be Mrs. Reimer's phone. Is that your phone? Alarm. Did you give it to her? I don't know. It was Mrs. Reimer's phone, and it was an alarm reminding her for something, and I don't know what it is. Hopefully it's not important. So I'm thinking that probably we'll have this many things between in and the stuff that we just did. So I should probably preemptively call that expression, if that's 0. Actually, this will really be 0, right? So we should call these ones 1s. And this 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is 1 now should be 10. And what's 0 should be 1. So let's go to expression 1 and just name it 10. And then we'll go to 0 and call that 1. Just preemptively. And we got to fix up a few things because it doesn't know that. And then in here, it doesn't know that 1 became 10. Okay, and then save that. Okay, in the grammar, 1 became 10. Actually, let's just do it by global search replace there. And then expression 0 becomes 1. Done, right? We have an error? We don't if we save. Yeah. Cool. Still passing our test. So, I want to add another level. Can we do dot? Where's dot used? Oh, dot's not even used in references. It's used, expressions is used in references. Okay, so that's, I don't need a level for that for expression. What about, yeah, these aren't either, right? So maybe I didn't need to make an expression 0 slot. These are all like, yeah, these aren't expressions. Okay, so then they move down 1. So good thing that this is easy to do, right? 1 becomes 0 again. And 10 becomes 9. And this becomes 0. This becomes 9. And then we go into here, turn all of these to 9s and all of these to 0s. Done. Easy peasy. Okay, so that means, yeah, that not and flip are the lowest, are the highest precedence operators, really. They're the lowest in the order of the grammar, right? And then along with the escape rule, which doesn't really have a precedence. And then in is way up here. So let me pick one in the middle. How about this? We'll do shift, because that's right above the not and flip. So that's 1. It's not as high order as flip and not, but it's lower than in. Hey there, Red he left you? Red he left you, hi. So we're gonna do left shift, right shift. Yes. I'm writing the grammar rules. Well, I'm porting the grammar rules from C to Rust for a DSL, which this particular DSL is for describing how to parse data. So files, protocols, kind of like the same idea as dissectors in Wireshark. So the idea is you have some data and you know what the format is. You can describe it in my language and then plug it into a tool that when you click on a byte, it just knows what it means. That's what I'm kind of working on right now. Yeah. So, but there are lots of kinds of expressions in my language, and I have to code them all. So we're going to do shift operators next. Yeah, so here, that would be like a level 1 expression, right? So that means like kind of this moves to here, and then this becomes a 1, and then another alternative 1 expression is a left shift. So that's, oh, and that has a certain associativity, right? It's left associative. So the way that left associative works is you do a 1 and then a 0. So if this is left shift, so this is operation box left shift. And then let's do the right shift while we're at it. This is right associative because if we have A, left shift B, left shift C, it would want to do, no, it's left associative, right? Yeah, left associative means if it's A, shift B, shift C, it's A, shift B, and then shift C, right? Because most things are like that. So that's how this works, right? Expression 0 can't be a left shift, but expression 1 can. So if it is a if it is a shift, it would be A shift B and then shift something else, which is not another shift. Yeah, I'm telling myself this to kind of hammer home that left associativity is same level on the left, 1 level down on the right. Okay, I think I got it. So, yeah, we have the rules. Let's have a test for it. So I'm just going to copy 0 to 1, expr 1. And here we'll just replace expr 0 with 1. And just reduce these test cases. Oh, I have to have, in tests, I have to declare the module. Mod expr 1. Go away. Okay. So I don't need these all these valid things. I can just skip to the first operator that... Actually, wouldn't it be better to just copy from expression 9? Like that. And then 9 goes to 1. And then I can just go to the in one and I can say it's left shift. So like 10... Let's do it this way. That's not going to work because it's going to match the in and integer, isn't it? I can't be smart about it. I'll have to be dumb about it. Okay. Yeah, so this is going to test like the associativity. So it's going to be like A L shift B, then L shift C. So it's like something left shift, something else, and then another left shift. A third thing, like 67, right? So just to make it understandable, it's like that. 10 left shift 42 and then left shift 64 is going to have 2 shifts in it. and it's the outer one. So these are both left shift. Comma. So this is the inner one. So it's 10, 42, and then that 67. Okay, and then I wanted to like show that if we put parentheses around the left two, it'll do no, the right two, it'll do the right ones first. So this is a left shift, or A, then left shift B, left shift C. That's not the best way to do it. It would be B, left shift C, then the other way around. It's like calculate A, then left shift B, left shift C. The thing is, I can't use, actually, I guess I can use parentheses. It takes it out of the name, right? So maybe that makes it easier to read. A, left shift B, then left shift C. A, then left shift B, left shift C. Okay, that, because now the names are distinct, but the parentheses got dropped. Okay, that works for me. So then the way we do this is with parentheses. So it's 10 left shift and then a parentheses around these ones. So we'll do it this way. Token L paren and R paren there. And I'll put these on the same line. I'll just indent it. So it's 10 left shift, the result of 42 left shift 67. So that means we change the order, right? So it's left shift of 10 and the expression of left shift 42 and 67. Cool. Do I need all this stuff? I think I do. So let's just run them. Okay, we have a grammar rule. Terminal left shift does not have a pattern. Oh, I forgot to write that. Okay. These terminals have to have a representation in token. Left shift is token left shift. I'm almost typing a bad naughty word there, but I'm fortunately not typing the naughty word. Okay, go back and run it again. Expression 1 tests. Oh, I got bugs. We got bugs. Oh, I don't have left shift operation declared. Let's add that. Operation. It would go here, right? Then R shift goes down. Oh, flip goes first, right? And this is R. There we go. I feel like I'm missing something. Yeah, I'm missing something. I'm missing a comma. That's what I'm missing. Run it. Pass the test. Of course they pass the test. Why wouldn't we pass our tests, right? 44 tests passed. Okay, cool. So I should probably call it here and continue in the morning. So now we have 3 levels of expressions. They're from least to most associative right now. And I guess the base one, expression 0, has all the things which aren't operators also. It has all the literals, which makes sense. And it also has the escape rule. So in their manual, they call that a term. Term. I didn't want to call it a term. They're all expressions, but they're and I guess what I did is I put these in with that, which I guess it doesn't really matter, right? Because he could have grouped these together. This is just being excessive, right? Because these can't contain factor anyway, there's no reason why you couldn't combine them. Can't combine expression with factor because expression has a factor in it. But you can put the terminals in factor because none of these, actually no, these have terminals. Do I need to worry about that for... Oh no, because this can, it's the unary operators are fine, right? For binary operators, I have to be careful, but for unary operators, it's always right associative because there's nothing on the left. So if it's not C, then it's C, not, and then you go from right to left. So it's not ambiguous, even if you put in these terminals with them. Okay, so I guess tomorrow what I'll do is I'll put in all of these other operations and make sure it works with the in, and then add the ones that are less associative. Actually, comma is not a part of an expression, and neither are these. So these can be in expressions, and these can be in expressions. So I'll be doing these tomorrow morning. That'll probably take all morning because it's so tedious. All right. So yeah, check out my example program while I go find someone to raid. Then I gotta go unconscious for a while. Oh, there's a whole different set of people I can raid because I don't normally stream in the evening. Who should I pick? Someone who's doing web dev or game dev or pigeon work, which is a chat client. I like Grim. Let's raid Grim. He's working on pigeon. Oh, I didn't see that message until now. Red, he left you. Is it cross-platform? Yeah, because it's written in both the original and the Rust are both cross-platform because we're not using anything that's specific to any platform. You can run Bison and Flex and Rust on pretty much every platform. Grin's been around forever. Of course he has. Starting to cough because I've been talking all day. I hope you guys enjoy RW Grim stream. I'll be back tomorrow in roughly 7 hours. I'm literally going to go to sleep, wake up, and then come back and stream again. All right. See you later. Bye.